In this module, we connect regulation and architecture for wallet-based KYC. We'll look at what relying parties are accountable for, how cross-border recognition works in the EU, and how trust is validated end-to-end. From there, we'll be ready to map these themes into concrete technical controls. You've already seen why eIDAS 2.0 exists, who the ecosystem players are, and how a wallet-based onboarding journey works in practice. You also defined the business scenario and the high-level architecture. Now we translate that foundation into specific regulatory expectations and operating limits for your design. Wallet-based KYC doesn't remove your regulatory duties. It changes the form of identity data, from messy documents to structured, high-quality attributes. You still need a lawful basis, clear purpose limitation, and minimization of what you request. You still have to validate the trust framework behind each credential, record how you made decisions, and keep evidence for audits. So architecture choices must embed compliance from the start, instead of bolting it on later as a legal afterthought. In wallet-based onboarding, the relying party is the one asking for user data, so regulators treat it as the main decision maker. It must clearly define why it needs each attribute and limit requests to what's genuinely necessary for that purpose. It also has to explain this to the user in plain language. Once data is received, the relying party must verify it, protect it, and apply all relevant privacy, KYC, security, and sector-specific rules. Data minimization starts with a simple question. What do we actually need to know to make this decision? Every attribute should map to a clear business or compliance purpose. If the goal is just to confirm legal age, you don't need a full birth date, address, and phone number. Wallet-based KYC lets you request only essential attributes, or even over 18 proofs, so you reduce risk, improve privacy, and still fully satisfy regulatory requirements. Purpose declaration is the story that connects the whole flow. When a user starts onboarding, the relying party should clearly say who they are, what attributes they need, and why, in plain language like verify your identity to open a regulated payment account. That same purpose needs to echo in the wallet request, the back-end policy, and the audit logs. If any step is vague or inconsistent, users lose trust and compliance teams lose defensibility. When a user taps approve in their wallet, they're only choosing to present attributes. That click is not automatically GDPR consent, and it's not your full legal basis for processing. You still need a separate lawful basis. For example, legal obligation, contract, or legitimate interest, and only sometimes consent. If you rely on consent, record the who, what, when, and purpose. And design the experience so users genuinely control sharing without pressure or dark patterns. To trust a presentation request, wallets need to know who is asking and why. That's the role of relying party registration. The organization is vetted, then its metadata is published. Legal name, domain, certificate, allowed purposes, and contact and policy details. Wallets use this to show users a recognizable verified requester. When metadata expires, changes, or is revoked, the ecosystem updates it, keeping accountability and trust intact over time. Once identity data reaches your systems, the main risk shifts from verification to misuse. First, restrict processing to the exact onboarding and compliance purposes you declared. Next, separate what you store. Raw presentations, extracted attributes, verification outcomes, and compliance evidence each deserve different protection and lifetimes. Enforce least privilege access for operators, support, risk, and audit teams. And design retention and deletion rules up front, because they drive your schemas and logging strategy. Cross-border recognition is about treating a trusted identity from another EU country as if it were local. With eIDAS 2.0, a customer can reuse wallet credentials issued elsewhere, and your role is to decide when those attestations are acceptable. Instead of trusting a specific national system, you anchor trust in EU and national frameworks, then validate each credential against them. This expands your market but demands stronger validation processes and careful regulatory interpretation. Interoperability isn't just, does this credential verify? It's, does it meet my risk rules for this product? Architects need a policy engine that reads each attribute, looks at its assurance level, the issuer category, and any evidence strength, then maps that to internal KYC requirements. Sometimes a credential is technically valid, but only good enough for a basic account, or it must trigger manual review for higher risk services. When a wallet sends identity data, it's just a claim. Trust validation turns that claim into usable evidence. First, confirm the credential really came from a trusted issuer, that its signature is valid and nothing has been altered. Then check it's still current and actually bound to the person in front of you. Only after these gates pass do you write attributes into the verified customer profile, or trigger rejection, retry, or manual review. Think of trust as a chain of explicit checks. Your architecture must enforce every time a credential is used. First, confirm the issuer is on an approved trust list. Next, verify signatures so the credential's contents and proofs are authentic. Then, query status to see if it's valid, expired, suspended, or revoked. Finally, bind the holder so the right person is presenting it. Each step should emit evidence for logging, monitoring, and exception workflows. Regulation becomes real when it shows up in architecture. Lawful request and purpose rules drive how you design presentation requests and onboarding flows. Cross-border recognition decides which issuers you trust and how your policy engine evaluates foreign credentials. Trust validation pushes you to design verifier services, status checks, and exception paths. And responsible data handling determines storage layouts, retention schedules, access controls, and the audit evidence your operations must consistently produce. Wallet-based KYC is an identity process, not just a UX tweak. You stay fully accountable for lawful, purpose-limited data requests, clear transparency, strong credential verification, and secure handling. Next, we map these duties to GDPR and privacy by design, then to AML and KYC evidence and concrete control requirements.